Assalamu alaikum. The lecture today is the differential equation. This equation is very important in mathematical analysis, and many real systems can be expressed or modeled with the formulation of mathematical equations such as electric system or mechanical or any other system. Mathematical equation in general can be classified into two main types: normal equation and differential equation. These two examples for the two types. The first one is the normal equation and the second is the differential equation. The main difference between these two types is the first equation, which is the normal equation, doesn't contain the differential part. While the differential equation must contain the differential part. The second main difference, or important difference between these two types, is that for the first equation we must find the values of the variable that satisfy the equation. The values must be found. The values of the variable must be found that satisfy the equation. While in the second equation, which is the differential equation, the function formula must be found. The function of the variable, of the differential variable, must be found, and there is no any value treated in the differential equation. Depending on the differential part, the differential equation can be classified further into other types: first order ordinary differential equation and second order differential equation, and any higher differential equation. In our study, we shall concentrate on these two types only: the first order and the second order. These two types of the first order ordinary differential equation, the differential part appear with first degree, so both of them is the first order differential equation. The solution of the first order differential equation may be difficult, maybe has many complex steps, so the first order differential equation can be classified to many categories to simplify the solution of differential equation. Here the differential equation is very simple. But the other differential equation is more complex. Return to the first one. Rearrange the equation by rearranging the equation. dy over y equal 3 dx. Integrating both sides, we can obtain, and by take the exponential of both sides, this is the final solution. This is the final solution of the first example. The constant c is appear because the unbounded integral, unlimited integral, there's no range for the integral, so the constant c must appear. The value of this constant can be found from the initial condition. This constant c can be found from the initial condition. The initial condition is the value of the y that must be found, the value of the variable y at the 0. The second example, as we said previously, is more complex with respect to the first one. There is a cosine function, there is a differential, there is a y variable multiplied by the function. A according to the categories of the first order differential equation, this function, this example, can be included in the general form of the first order differential equation. This is the general form, first order differential equation, dy over dx plus p of x multiplied by y equal to qx. This is the general form of the first order differential equation. The solution of this formula is obtained by finding the integrating factor. The integrating factor is the exponential integral of the function p of x. This is the integrating factor that must be found to solve the first order differential equation if it can be arranged in this form. When the first order differential equation can be arranged in the following form, it can be solved by finding the integration or the integrating factor. The integrating factor now is exponential to minus sine x. Multiply this integrating factor to both sides of the differential equation, we get the differential of y multiplied by exponential minus sine x equal e exponential minus sine x multiplied by cosine x. Then integrating both sides, we get y multiplied by e minus sine x equal minus e minus sine x plus c, and again c is according to unlimited integral. The final solution is y equal minus 1 plus c multiplied by exponential sine x. This final solution is obtained by multiply both sides by e plus sine x, not e minus sine x. To cancel this factor, we multiply both sides by exponential sine x. So the final solution is